Good afternoon, everyone. Good afternoon. Students, before starting today's lecture, just please everyone let me know in the chat box that my audio voice is clear or not and the screen is visible or not. Quickly let me know everyone in the chat box. Yes, please everyone. Nalavade, Samadhan, everyone, please let me know in the chat box so that we can start with today's lecture, everyone. Audio is clear? The screen is visible or not? Screen is visible? Okay. Okay. So we can start with today's lecture then, right? Okay. So student, in the last class, we discussed about the family of circle, right? We discussed about the family of circle. So in today's class, we are going to look into the common tangent to two circles, and then we will move on to the radical axis. Okay. So this will be the today's agenda. Okay. So we will be using the some concept from the family of circle in the radical axis. Okay. So this is a very important and very easy topic that sometimes directly in the JEE mains and other competitive exam, they directly ask you the question that tell me how many tangents are common between these two circles. Okay. So all those type of questions will be answered in today's class. Okay. So let's start with today's lecture, everyone. So common tangent to two circles. Okay. So there are mainly two types of common tangent when we see between the two circles. The first one is called direct common tangent, means this type of things. Okay. And second we call transverse common tangent or indirect common tangent, means like this. So what is the difference between the direct common tangent and transverse common tangent? In the direct common tangent, center of both circle lie on the same side of tangent. See, this is center of first circle, this is center of another circle. So with respect to this tangent A1P, so center of both circle lie on the same line, and with respect to this tangent also, the center of circle is lying above the line, right? So in the direct common tangent, center of the circle will lie on the same side of the line, in same side of the tangent. But in the indirect or transverse common tangent, the center of the circle will lie on the opposite side of the tangent. Okay. See, with respect to this tangent A1, A2, C1 and C2 lie on the opposite side of the tangent. Clear? Is this clear? So the difference between the direct common tangent and transverse common tangent is clear. So in the direct common tangent, center of the both circle will lie on the same side of the line. And in transverse common tangent, the center of the circle will lie on the opposite side of the tangent. Okay. I hope this is clear to you. Okay. So in student, there are so many common properties with respect to these two, transverse common tangent and direct common tangent, that we are going to look into now. Okay. So let's say in the direct common tangent, okay, in the direct common tangent, this is one tangent and this is another tangent, right? So these two tangents are intersecting at point P. Okay. These two tangents are intersecting at point P. So there are two circles. With these two circles, there are, let's say this is two direct common tangent, right? So we can see that these two tangents are intersecting at point P. Okay. Now student, tell me triangle PC2A2 and triangle PC1A1, right? Triangle, these two triangle PC2A2, right? This triangle, since this is a radius and this is a tangent, so this angle will be perpendicular, this angle will be 90 degree. Similarly, another triangle that I'm talking about is this triangle PC1A1. So this is also 90 degree, right? And I have told you already that the angle between the tangent, angle that this tangent is inclined on the C1, C2 line, means this angle and this angle will be equal. Yes or no? Because the tangent will make tangent inclined equally on the line joining between the two centers C1, C2. Yes or no? So this angle and this angle is equal. So automatically this angle and this angle will also be equal. Yes or no? So you can say that these two triangle PC2A2 and triangle PC1A1 are similar. Is this clear? Okay, if these two triangles are similar, so you can say that PC2 upon PC1 is equal to A2C2 upon A1C1. Yes or no? If these two triangles are similar, then the ratio of the corresponding side will also be equal. Yes or no? So it implies PC2 upon PC1. कितना है? What is A2C2? R2. What is A1C1? R1. Right? Yes or no? Clear? So you can say that it looks like the point P divides line joining C1 C2 in the ratio R2 is to R1 externally. Yes or no? Externally. Is this clear? Because PC2 upon PC1 is equal to R2 upon R1. So the point P is at such position, it means where it divides the line joining C1 C2 in the ratio R1 is to R2. Yes or no? Yes or no? Clear? Okay. So similarly, if it is clear, so similarly in this triangle where we are getting the transverse common tangent, you can say that triangle. Which triangle? Let me use some different sketch pen. 1 second. Orange. Okay. So you can say that triangle. Let's say these two tangent, these are the transverse common tangent. Yes or no? Are intersecting at point Q. So you can say that triangle Q A1C1 and triangle Q A2C2. These two triangle, this angle is 90 degree, this angle is 90 degree. This angle is this angle equal. So similarly, this angle and this angle will be equal. Yes or no? So these two triangles are also similar. If these two triangles are also similar, then in the same way, the ratio of the corresponding side should be equal. Yes or no? Yes. Hi Abhiskar. Hi Sagar. Yes or no? So you can say that QC1 upon QC2 कितना होगा? QC1 upon QC2 is nothing but C1A1 upon C2A2. Yes or no? Clear? It implies QC1 upon QC2 कितना आ गया? What is A1C1? R1. What is A2C2? R2. Right? Yes or no? Clear? So you can say that Q divides line joining C1 C2 in the ratio R1 is to R2. Yes or no? And C1 C2, see, this is C1, this is C2, right? And somewhere P point is lying here, right? What is PC1 upon PC2? PC1 upon PC2 is equal to R1 upon R2. But this is dividing internally. Yes or no? Yes. So it implies we can see clearly here there are two important points that we can see. First is the point P, the point of intersection of the two direct common tangent is at a point where that point divides the line joining C1 C2 in the ratio R1 is to R2 externally. Similarly, the point of intersection of the indirect common tangent, transfer common tangent, which is Q point, this divide the line joining C1 C2 in the ratio R1 is to R2 externally. Yes or no? This divides in the ratio R1 is to R2 externally. Is this clear so far? Tell me quickly in the chat box, everyone. Is this clear or not? Everyone, reply me in the chat box. Is this clear? Is this clear? Everyone, I'm talking to everyone. Janvi, Chitra, Durga, Mahesh, Omkar. Everyone. Is this clear or not? Okay. If it is clear, student, if it is clear, then you see this same concept we have already seen in the straight line chapter, right? Where when we talked about the where we talked about the harmonic conjugate. Did you remember? This is C1, this is C2, this is point Q, this is point P. Yes or no? Yes or no? So PC1 upon PC2 is equal to R1 upon R2 and R1 upon R2, yes, and QC1 upon QC2 is equal to R1 upon R2. Point Q is dividing C1 C2 in the ratio R1 is to R2 internally. Point P is dividing the line joining C1 C2 in the ratio R1 is to R2 externally, right? P is dividing externally and Q is dividing internally. So you can say that P and Q are harmonic conjugate of each other. Harmonic conjugate of each other. Yes or no? These things we have already talked about in the straight line chapter. Is this clear, everyone? Tell me quickly. Is this clear? So what does this mean? What does this mean? It means C1Q, C1C2 and C1P. These three are in HP. Is this clear? This is very, very, very important point. Okay. I have seen so many question paper where they ask this concept directly in the exam. Okay. So that's why this is very important topic. Okay. Is this clear, students? Is this clear? So P and Q are known as harmonic conjugate of each other because these points are dividing the C1 C2 in the same ratio, but one point is dividing externally and another point is dividing internally. Clear, everyone? Is this clear? Okay, very good, very good. Okay, so now you understand that what is direct common tangent, what is indirect common tangent, right? And the important point also we have noted here that the P and Q will be harmonic conjugate of each other. Tell me, is there anyone who doesn't understand this concept? Is there anyone? Is this clear to everyone? Tell me quickly in the chat box, students. Students, tell me everyone quickly in the chat box. Is this clear or not? Do you have any doubt regarding this? JNV Davangri, JNV Chitra Durga, everyone. Okay, Sindhe, no problem. Sindhe, what I said is, see, there are two type of tangent: direct common tangent, where the point where the center of the circle lie on the same side of the tangent, and there is a indirect common tangent where the center of the circle lie on the opposite side of the tangent. Okay, so here I said that if there is a direct common tangent, then this point P, which is the point of intersection of these two direct common tangent, point P will divide the line joining C1 C2 in the ratio R1 is to R2 externally, and point Q, which is the point of intersection of transverse common tangent, which is indirect common tangent, it will divide the line joining C1 C2 in the ratio R1 is to R2 internally. Okay, so it means that there is 2 points C1 C2. This is a line joining C1 C2. Point Q dividing C1 C2 in the ratio R1 is to R2. Point P dividing C1 C2 in the ratio R1 is to R2 externally. So in the straight line chapter, I have already told you, if there are 2 points which dividing the line joining in the same ratio, but one point is dividing externally and another point is dividing internally, then we will say that these 2 points are harmonic conjugate of each other, which means C1Q, this distance, C1C2 and C1P, these three distance are in HP. Clear? Clear? Is this clear now? Okay. Tell me everyone quickly. Is this clear? Okay. So student, if it is clear, then let's proceed. Okay, let's proceed. Very good, JNV Davangiri. Very good. Very good. Okay. So now this point I have already repeated. Okay, I have just written here again that the direct common tangent meet a point which divide the line joining center of the circle externally in the ratio of their radius, and the transverse common tangent meet a point which divide the line joining center of circle internally in the ratio of their radii. Okay, the same thing I have just written here again. Okay, if it is clear, then let's move. Okay, Now let's talk about the position of circle and the number of common tangent. Okay, there are only two type of tangent possible on the two circle. If two circle are given, then there are only two possible type of tangent. One tangent is such that this center of the circle are lying on the same side, and another tangent is such that the center of the circle are lying on the opposite side. Okay, these two type of possible tangent are possible on a two circle. Okay, okay. If it is clear, then let's talk about the case one. Case one is such that two circles are separated. Okay, see student, I'm going to tell you this case one by one. There are 4-5 cases, and in each cases you have to answer me how many common tangent is possible. Okay, the first case is if two circle are separated. Separate कैसे होंगे circle? If the distance between the two centers C1 C2 is greater than the sum of their radius. Yes or no? So if two circle are separated, then you can say that C1 C2 is greater than R1 plus R2. Clear? These are the conditions also you have to remember directly. Okay, so if the question asks you find whether the two circles are separated or touching each other or internally or intersecting each other, or are one circle is within another circle, so how you are going to check? These cases I'm going to tell you. First case is if two circles are separated, means there is no point of intersection between the circle and two circles are away from each other. Okay, so C1 C2, the distance between two circles is greater than R1 plus R2. Clear everyone? Okay, so if it is clear, now tell me everyone in the chat box number of common tangent. Number of common tangent. Can anybody tell me in the chat box how many common tangent are possible? Number of common tangents. Anyone? Okay, Salish is saying 2. Okay, any other? Total number of common tangent I'm asking. Okay, I'm not asking that total number of direct common tangent or total number of indirect common tangent. Okay, it would be fun if I ask you this question again, that total number of direct common tangent. Okay, so first thing I should separate here, since I'm going to write this again and again. So let me make a ground rule that direct common tangent, I will be denoted as DCT. Okay, and transverse common tangent I will be denoted as TCT. Clear? So now can anybody tell me how many direct common tangent are possible between C1 and C2? Any guesses? Students, I'm asking to you, any guesses how many direct common tangents are possible? 1. How is this possible? 2 direct common tangent, na? See, Salis, one tangent is something like this, and similarly the another tangent would be somewhere here. Yes or no? So there are 2 direct common tangent are possible. Yes or no? Yes, very good. So direct common tangent are 2. Can anybody tell me in the chat box how many indirect common tangent are possible? Which transverse common tangent? How many of them are possible? Yes. 2 indirect common tangent. One would be something like this. Yes or no? And another would be something like this. Right? So there are 2 transverse common tangent and 2 direct common tangent. Is this clear? So this is direct common tangent and this is transverse common tangent. So if I ask you what is the total number of common tangent between C1 and C2, between the circle S1 and S2, these two circles. Let's say this is a circle S1 is equal to 0 and this is a circle S2 equal to 0. So 2 direct common tangent, 2 transverse common tangent, total number of common tangent will be 4. Very good, Salis, very good. Clear everyone? Case 1, when the 2 circles are separated, then the total number of common tangent are 4, out of which 2 are direct common tangent and 2 are transverse common tangent. Is this clear? Okay. If it is clear, then let's move on to the case 2. Case 2 क्या बोल रहा है? Case 2 is if 2 circles are touching each other, means What is the condition for two circles should touch each other? Let these two circles are touching at point P. It means C1, C2 should be equal to R1. This is R1 and this is R2. So two circles should be, the distance between the center C1, C2 should be R1 plus R2. Then only the two circle is touching each other. Yes or no? Okay. If it is clear, now again tell me number of direct common tangent. Number of direct common tangent. How many direct common tangent are possible? Anyone? Direct common tangent. Salis, I'm asking direct common tangent. Pramod. Yes, very good. Very good, Pramod. Two direct common tangents are possible. Yes, very good. Yes or no? One direct common tangent, something like this, right? And another direct common tangent would be something like this, right? So these two direct common tangent are possible. Okay, very good. Now can anybody tell me how many indirect common tangent, means number of transverse common tangent? How many transverse common tangent is possible? Very good, Pramod. Very good. One transverse tangent is possible, and it is quite clear that this transfer common tangent is something like this only. Yes or no? Right? So this red is direct common tangent and this orange is transverse common tangent. Yes or no? So total number of tangent कितने आ गए? Total number of common tangent. Total. Yes, very good. Very good, Karusana. So total number of common tangent is 2 plus 1, 3. Clear? Is this clear? Okay. Okay. Right. See, the conditions are important. And yes, Ruhatak has raised his hand. Okay. Ruhatvak, do you have any doubt? You can ask me in the chat box. Okay, if you have any doubt, would you please ask me in the chat box, or are you saying that you have everything is clear to you? Okay, you can type me in the chat box if you have any doubt. Okay. So if two circles are separated, then C1, C2 is greater than R1 plus R2, and in that case, there are 4 common tangent, 2 transverse common tangent, and 2 direct common tangent. Case 2 is if two circles are touching each other, then condition is C1, C2 is equal to R1 plus R2. Then in this case, there are 3 common tangent, 2 are direct common tangent, and 1 is transverse common tangent. So total number of common tangent is 3. I hope this is clear to you. So now let's move on to the case 3. Case 3 is saying that if two circles are intersect at 2 points, and this is very important because many people forgot this condition on the left hand side. Okay, if two circles are intersecting at 2 points, clearly it is saying 2 points, then the condition is C1, C2 should be less than R1 plus R2, and C1, C2 should be greater than R1 minus R2, mod of R1 minus R2. Can anybody tell me in the chat box why this case is clear? ये तो समझ में आता है कि C1, C2 should be less than R1 plus R2 if two circles are intersecting. But why this is condition also applicable that C1, C2 should be greater than mod R1 minus R2? Can anybody tell me in the chat box? Anyone? Any guesses? Yes, try to think why we have written that this condition should be satisfied, that C1, C2 should be between R1 plus R2 and mod of R1 minus R2. Anyone? Okay. See, clearly it has saying that the two circles are intersecting at 2 points. Yes or no? If tell me if this is this situation, let's say one circle is this and another circle is this, means these two circles are touching each other and this one circle is internal inside of the second circle. Let's say this is C2 and this is C1. Okay. If this is the case, then tell me what is the condition for that? Is that this is C1, C2, right? So C1, C2 is equal to mod of R1 minus R2. If this is becoming possible, then the circle are touching each other. But we don't want the circle to touch each other internally. We want circle to intersect at 2 different points. So that's why I am taken that C1, C2 should be strictly between R1 plus R2 से तो छोटा होना चाहिए, but it should be greater than mod of R1 minus R2. Clear everyone? Clear? Do you have any doubt in this? This condition is very important. I have seen so many students, they did mistakes and does mistake every time. Okay, that's why this condition is very important, and this case 3 is particularly very important because you will be coming across the case 3 more often than the other cases. Okay, so that's why you should remember that the condition for the two circles should intersect is that C1 C2 is between, should be less than R1 plus R2 and should be greater than mod of R1 minus R2. Okay, चलो ये तो बात होगी. Now can anybody tell me number of direct common tangent? Total number of direct common tangent. Anyone? Direct common tangent. कितनी होंगी tangent? Direct common tangent. Anyone in the chat? Anyone? Tell me. Students, how many direct common tangent are possible? Can anybody tell me in the chat box? How many direct common tangent are possible if two circles are intersecting? Yes, I am waiting. Yes, very good, Salis. There are two direct common tangent are possible. Yes or no? One is like this and another would be like this. Yes or no? So number of direct common tangent are 2. Can anybody tell me in the chat box number of transverse common tangent? Number of transverse common tangent. Yes, very good, Pramod. Very good. Transfer common tangent इस केस में तो कोई आएगी ही नहीं. Yes or no? So that's why the number of the transfer common tangent is 0. Yes or no? There will be only the case where the direct common tangent is existing. Okay. Yes, very good, Sagar. Very good. So it implies total number of tangent कितना हो गया फिर? Total number of common tangent. Common tangent. कितना आ गया? 2 only. Clear? Clear? Is there anyone who have doubt in the 3 cases so far that we have discussed? Okay, very good, Abhishek. Very good. Okay. So if it is clear, so shall we move to the next case, which is the case 4, and which is the same case that we have discussed here. If the two circles are touching each other, okay, but internally. So the case 4 is if two circles are touches each other internally, then what is the condition? This is the condition that C1 C2 is equal to mod of R1 minus R2, means C1 C2 should be equal to the difference of their radius. Yes or no? This is C1 C2, this is R1 and this is R2, so R1 minus R2 is this only. Yes or no? If two circles are touching each other, then the C1 C2 should be equal to mod of R1 minus R2. Okay, clear everyone? This condition is clear? Okay, if it is clear, so can I ask you total number of common tangent? Okay, total number of direct common tangent कितना होगा? पहले तो ये बताओ, direct common tangent कितना होगा? Yes, Pramod, the total number of tangent is 1, but would that tangent be the direct common tangent or would that tangent be the transverse common tangent? Which one it is? Number of direct common tangent, total number of transverse common tangent, direct common tangent. Okay, see where is that tangent? The tangent is at the point where these two circles are touching. Yes or no? Okay, and clearly the C1 and C2 are lying, the center of the circle are lying on the same side of this tangent, so it implies this tangent is nothing but direct common tangent only. Yes or no? Right? From the definition where I have told you the definition, how you will identify between the direct common tangent and the indirect common tangent is that center of the circle should lie on the same side, then it is a direct common tangent. If the center of the circle are lying on the opposite side of the tangent, then it is a transverse common tangent. So here the C1 C2 are lying on the same side, so the number of direct common tangent is only 1 and there is no transverse common tangent is possible. Yes or no? So total number of transverse common tangent is 0. Yes, very good, Shubham. Very good. Okay. Okay. So if it is clear, then टोटल नंबर ऑफ कॉमन टेंजेंट कितना आ गया, टोटल नंबर ऑफ कॉमन टेंजेंट, तो वो तो एक ही हुई, टोटल नंबर ऑफ कॉमन टेंजेंट इज 1. क्लियर? इज दिस क्लियर? Okay, if it is clear, then let's move on. Very good, Shubham, very good. So let's move on to the next case, which is case 5. Case 5 is if one circle is completely lying inside the second circle. Okay, if one circle is completely lying inside the second circle, this is the case. So how it will be possible? If C1 C2 is strictly less than R1 minus R2. Okay, C1 C2 is strictly less than R1 minus R2, means distance between their centers should be less than the difference of their radius. Okay, see, this is C1, this is C1 C2, and this complete distance is R1 and this distance only is R2. So अगर आप R1 में से R2 हटा भी दोगे, then how much, what is the distance left? This distance plus this distance. Yes or no? Which is clearly R1 minus R2 से, तो which is clearly greater than C1 C2. Yes or no? So that's why C1 C2 should be less than mod of R1 minus R2. Okay, if it is clear, then this is also again very important condition. Okay, then can anybody tell me number of direct common tangent, number of transverse common tangent, and total number of common tangent? Total number of common tangent. Anyone in the chat box? 0. Yes, very good. So there would be no direct common tangent. कोई tangent आएगा ही नहीं. Yes or no? क्यों नहीं आएगा? क्योंकि अगर आप इस सर्कल पे टेंजेंट ड्रॉ करोगे तो दूसरे सर्कल पे टेंजेंट बन ही नहीं सकती, वो तो सर्कल को इंटरसेक्ट करते हुए चली जाएगी. यस और नो? सो दैट्स व्हाई द नंबर ऑफ डायरेक्ट कॉमन टेंजेंट विल बी 0. सिमिलरली द ट्रांसफर कॉमन टेंजेंट भी कोई नहीं आएगा. अगर ना डायरेक्ट कॉमन टेंजेंट है एंड ना ट्रांसफर कॉमन टेंजेंट है, तो इट मींस नो, देयर विल बी नो कॉमन टेंजेंट. क्लियर? इज दिस क्लियर? टेल मी क्विकली इन द चैट बॉक्स. सो ऑल 5 केसेस आर क्लियर. तो देखो ऐसा है कि देर आर 2 सर्कल. ओके, 2 सर्कल है. पहले बोथ सर्कल आर अवे फ्रॉम ईच अदर, देन द C1 C2 इज ग्रेटर देन R1 plus R2. Then we are bringing these 2 circle to each other. Okay, near to each other. Then the circle then touches each other. Then C1 C2 becomes R1 plus R2 के बराबर. Then the circle are intersecting. If the 2 circle are intersecting, then the C1 C2 should be less than R1 plus R2. But we have to make sure these 2 circles are intersecting at 2 different points. Then the C1 C2 should be greater than mod of R1 minus R2. फिर और नजदीक लेके आओ सर्कल को. Then one circle is completely lying inside the another circle but touching internally. Then C1 C2 should be equal to difference of R1 minus R2. और पास में लेके आओ. Then C1 C2 is less than mod of R1 minus R2. Yes, Subham, these classes are being regularly and since the quite some time also. Okay, I don't know why you are asking me this question again. Okay, is this clear? Okay, so these 5 cases are clear. Okay, so now let's solve couple of questions on basis of this. Okay, so the first question is again, find the number of common tangent to 2 circles. Okay, I'm giving you 1 minute. If you understood very clearly, then there should be no problem in answering this question. Everyone answer me quickly in the chat box. How many number of common tangent are possible between these 2 circles? One circle is this and another circle is this. Everyone, I'm giving you 1 minute. Everyone, tell me quickly in the chat box. Quickly let me know in the chat box. What is the answer? Answer everyone. 1 minute. You have 1 minute. Okay. Quickly. Be quick with your calculation. Okay. Answer students. Number of common tangent between these 2 circles. Just find the C1 C2 and the R1 plus R2 or R1 minus R2 and compare which is the case is possible and then answer the question. Simple. Okay. Quickly everyone answer me in the chat box. Students, anybody got the answer? Anyone? Should I ask? Should I start? Okay. So then let me solve this question. Okay. Solution is, what is this circle? Let's call this circle S1. Circle is x square plus y square minus 2x minus 4y equal to 0. What is the center of the circle? C1. Let's call this center C1. What is the center of circle? Minus half coefficient of x, which is 1, minus half coefficient of y, which is 2. What is the radius of this circle? Radius of circle is under root of g square plus f square minus c. So root 5. Clear? Let's call this circle S2. S2 is x square plus y square minus 8y minus 4 is equal to 0. Okay. So what is the center of this circle? C2. Quickly let me know in the chat box. What is the center of this circle? Center of the circle. Everyone should reply fast. You should be very fast with these answers. Center of the circle is center of C2. Quickly everyone. Yes, I'm solving the question, but it's quite no Subham, it is not difficult. You should focus here. Yes, very good Pramod, very good. The center of the circle is 0, 4. Okay. So tell me, what is this radius of the circle? Let's call the radius R1 and let's call this radius R2. What is the radius of circle? G square plus f square minus of c. C is minus 4. So this is root 20. What is root 20? 4 into 5. So R2 is nothing but 2 root 5. Clear? Is this clear? Okay. If it is clear, so R1 pata chal gaya, R2 pata chal gaya, C1, C2 we also have. So first of all, tell me what is C1, C2? C1, C2 is under root of 1 minus 0 ka whole square plus 2 minus 4 ka whole square. So C1, C2 is nothing but 4 plus 1 root 5. C1, C2 तो यही आ गया. See, R1 is root 5, R2 is 2 root 5. What is mod of R1 minus R2? Root 5 minus 2 root 5. इसका magnitude ले लो, वो तो 2 root, which is nothing but root 5 only. Yes or no? Which is nothing but root 5 only. Clear? Clear? So what you can observe here, that C1, C2 is nothing but mod of R1 minus R2. It implies C1, C2 is equal to mod of R1 minus R2. So which is this case? Yes, it is easier, as I said. Which is this case? This case is something like this. This is one circle and another circle is something like this. Okay. And this is C1, S2 have a bigger radius. So let's say this is S2, this is S1, right? Let's call this C1. Let's call this C2 and let's call this C1. So this is the case, right? So it implies C1, C2 is equal to R1 minus R2. It implies the circle, one circle is touching internally the another circle. Yes or no? So number of common tangent कितना आ गया फिर? Number of common tangent. Yes. Number of common tangent is one only. Yes or no? So this is the only common tangent which is possible. Yes or no? Is this clear, students? Is this clear? Everyone quickly respond me in the chat box. Okay. Yes, very good, Subham, very good. So C1, C2 was equal to mod of difference between the radius. So which was the case? Which is this case? Case 4, I think. Yes or no? When the one circle is internally touching the another circle. So in that case, number of common tangent is one only. And if somebody is asking which tangent, direct common tangent or indirect common tangent, that also you can answer because this is a direct common tangent. C1, C2 are lying on the same side of the tangent. Clear? Okay. If it is clear, then let's move on to the next question. Okay. Let's move on to the next question. This question. Everyone, again, answer me this question. I'm giving you 1 minute to solve this question. Okay. Tell me in the chat box which is the correct answer. A, B, C, D, which option? Okay. At the end of the 1 minute, I will launch a poll. Okay. So everyone quickly solve this question and let me know the answer in the chat box, everyone. Number of common tangents. Yes, very good, everyone. Quickly, let me know in the chat box. Yes, A, B, C, D. You can answer me in the chat box also. Okay. You have 1 minute to solve this question, everyone. Solve this question. The circle, one circle is x square plus y square equal to 16, and another circle is x square plus y square minus 2y equal to 0. Okay. Everyone, quickly let me know the answer in the chat box. What is the answer? What about the other people? Shraddha, Sandeep, and Vishal. What are you doing? Tell me the answer now. Okay. I got one answer from Pramod. What about the other people? I want answer from all of you. Answer, everyone. JNV Davangri, Shraddha, Vishal, Sandeep, Sindhe, Subham, everyone tell me quickly in the chat box. Everyone. Okay, so I'm launching a MCQ poll. Everyone, please participate in the MCQ poll. And the students from the YouTube live, you can answer me in the comment section, everyone. Yes, I'm seeing the mix between some people are saying B, some people are saying C. There are other peoples now in the class. So what about the other? Tell me the answer quickly in the chat box. Quickly. Okay. So more people are saying C, B. Okay, let's see. Let's see. Okay. Okay. So I'm ending this poll. Okay. I'm ending this poll. So let's see how many of you are correct. Okay. So let's call this circle S1 and let's call this circle S2. Okay. B is the answer. Okay. Subham is also saying B. Okay. Let's see. So S1 is a circle which has center. This is circle S1. The center is 0, 0. So C1 is 0, 0 and R1 is the radius of circle which is under root of 16 which is 4. Similarly, S2 is a circle. Center of the S2 is 0, 1. So let's call the center C2 is 0, 1. And what is the radius? Radius is 1 only. Yes or no? Radius is 1 only. Clear? Clear? So far clear? What is C1, C2? C1, C2 is nothing but 0 plus 0 minus 1 ka whole square which is 1. So C1, C2 is 1. Okay. Okay. C1, C2 is 1. And what is mod R1 minus R2? Mod R1 minus R2 is 3. 4 minus 1, 3. So what you can see here, C1, C2 is less than mod R1 minus R2. So this is nothing but fifth case. Remember, one circle is here and another circle is like this. Yes or no? 1 second. Okay, yeah. So one circle is here and another circle is here. Okay. Is this clear? Which circle have bigger radius? See S1. So S1 is this and S2 is this. Is this clear, everyone? So how many common tangent are possible? The situation is like this only. Yes or no? So it implies 0 common tangent. Case fifth aa raha hai to tangent. So none of you were correct. Okay. So which is the answer? Yes, very good, Pramod. Very good. So A is the answer. So number of common tangents between these two circles are 0. Clear, everyone? Everyone, is this clear? Or do you have any doubt with this? Is this clear? Quickly let me know in the chat box. Is this clear or not? Okay, okay. Okay. So student, if it is clear, so let's move on to the next topic, which is radical axis. Okay. Which is radical axis. So student, this is a very powerful tool. Okay. Because see, in the family of circle, no problem, Subham. The full credit to on. See, I don't see if the somebody is getting the wrong answer. So I don't judge those people also. What I judge that people are even not trying. Okay, that is the bad thing. Okay, At least you have tried. Okay, if you are trying and you are getting wrong answer, so when I'm telling you the answer, in that process you will learn something, right? But if you have, even if you haven't started even solving the question, how you will know that you have understood or not? Okay, so no problem, 100% marks for the efforts. Okay, so in the future also, whenever somebody give you problem, just give your 100% in trying. Okay, if you are ensured that you have given your 100%, so eventually you will see that question will start becoming, okay, question काफी अच्छे से बनने लगेंगे फिर. Okay, so now let's talk about the radical axis. Okay, radical axis, student, is a very powerful tool. Okay, in the family of circle, when I was talking about the family of circle, I said that the family of a circle passing through the point of intersection of S1 and S2. Let's say this is a circle S1 and this is a circle S2. The family of circle, if the circle is passing through the point of intersection of S1 and S2, means these 2 points. So one circle would be somewhere like this, yes or no? Another circle may be somewhere like this, yes or no? So it can be given as S1 plus lambda, S2 equal to 0, but lambda cannot be equal to -1, because if lambda is becoming -1, then you will get a line, not a circle. Okay, okay, so now let's talk about the radical axis. Okay, that was the introduction that I have given you in the starting of the family of line. Okay, so now let's talk about the radical axis. What is the radical axis actually? Radical axis of two circle is the locus of point whose power with respect to two circle are equal. What do you mean by power? That is also I have already explained. Okay, power of a point means, let me just do it again here. Power of a point. Can anybody tell me in the chat box what do you mean by power of the point? Let's say this is a circle S and this is a point P, x1 comma y1. If I ask you what is the power of a point P with respect to x, what is the answer? Can anybody tell me the answer? Power of a point. This thing I have already taught you in the last classes. Previous classes में discussion हो चुका है. Anyone? Power of point means, पावर ऑफ पॉइंट क्या होता है? लेंथ ऑफ टेंजेंट का होल स्क्वायर. मींस फ्रॉम पॉइंट पी यू ड्रॉ टेंजेंट and the length of this tangent is, let's say LT, right? Length of tangent is LT. So length of tangent का square. And what is the length of tangent? Length of tangent is nothing but under root of S1 only. Put the point inside the circle, put the point on the circle after making coefficient of x square and y square 1. So power of point is nothing but S1 only. Clear? Power of point is just put the point in the circle, equation of circle, whatever the value you are getting, that is the power of that point. Clear everyone? Okay. So it means the two circle are there. Let's say this is one circle and this is another circle. Okay. So radical axis kya hai? It is a locus of a point. Let's say this is a point P which is h comma k, such that whose power with respect to two circle is equal. Means if I draw a tangent, first of all this point P, let's say, align outside of these two circles. So it means from this point P there are two possible tangent are possible on this circle S1 and this circle S2. Yes or no? Yes or no? Let's call the S1 is nothing but x square plus y square plus 2g1x plus 2f1y plus c1 is equal to 0. And let's call S2 is x square plus y square plus 2g2x plus 2f2y plus c2 is equal to 0. Okay. Okay. So from the point P is, let's say, lying outside of these two circles. So it is, so we have already told, if the point P is lying outside the circle, then there are two possible tangents. There are two possible tangent are possibility of two tangent on the circle S1, and clearly two possible tangent are also on the circle S2. Okay, let me just do this tangent again. Okay, is this clear? Is this clear, students? Okay, okay. So what is power of point? Power of point is nothing but the length of tangent ka square. If the power of point is equal, it means the length of tangent from the point P on the two circle is equal. And already this point P, these two tangents are already of the same length, yes or no? And since this is a locus of a point such that the length of tangent is equal on the both circle, it means this length and this length is equal, and since this length and these are the two common tangents, so this and this is also equal, yes or no? Let's call this point A, let's call this point P. Means locus is such that PA is equal to PB only. Okay, locus is such that PA is equal to PB. That is known as power of point, and that is the definition of the radical axis. Radical axis of two circle is the locus of point whose power with respect to two circle are equal. What is the power? Just power of point is length of tangent ka whole square. Okay, find the length of tangent from point P on a circle, square it, you will get power of point. Clear? Clear everyone? So from the definition of the power of point, you can say that under root S1 whole square, this is the power of point from, let me just do it again with the basic. Okay, according to the definition, so locus is such that length, power of point of P on circle S1, length of, it means length of tangent from P on S1 ka square, this is the power of point, should be equal to length of tangent from P on S2 ka square. This is the locus. Okay, is this clear? How many of you understood this? Tell me quickly in the chat box, how many of you understood this? Clear? Very good, Vishal. Very good. Very good. If it is clear, then what is the length of tangent from point P on S1? Under root S1. Yes or no? Under root S1. Take the root and just put the point inside the circle. Yes or no? Put the point on the circle. So under root S1 ka square is equal to under root S2 ka square. Means S1 is equal to S2. Means S1 minus S2 is equal to 0. So this is the equation of radical axis. Equation of radical axis. Okay, applicable only after making coefficient of x square and y square is equal to 1. First, you have given two circle, make the coefficient of x square and y square 1 in the both circle, then do the S1 minus S2 equal to 0. That will give you the radical axis. Is this clear? Is this clear everyone? Okay, so what is S1? S1 is x square plus y square plus 2g1x plus 2f1y plus c1 minus time x1 is x square plus y square. Sorry, the point we should put, right? Because S1 minus S2 is given. Okay, S1 minus S2 is given. Okay, so just let me erase this. Okay, so what is locus? अभी तो locus निकाल रहे ना. Locus is nothing but put the point S1 minus S2. So h square, put the x with h and k with y only. Yes or no? Sorry, y with k. Yes or no? When you put h comma k, so you will get h square. S1 is h square plus k square plus 2g1h plus 2f1k plus c1 into, sorry, minus h square plus k square plus 2g2h plus 2f2k plus c2 is equal to 0. Okay, so as you can see, c1 h square cancel. What you are getting? 2g1 minus 2g2 into h plus 2f1 minus 2f2 into k plus c1 minus c2 is equal to 0. But now for the locus, what we do? For the locus, what we do? Just 1 second, student. 1 second. Let me add one. Yes, let me just add one more slide. Yeah, for the locus, what we do? Replace. This is the locus. Okay, this is the locus. Make no mistake. This is the locus S1 minus S2. But when we found the locus, replace H with X, K with Y. So now replace H with X and K with Y. तो कितना आ गया? 2G1 minus 2G2 into X plus 2F1 minus 2F2 into Y plus C1 minus C2 is equal to 0. So this is the equation of radical axis. Okay, this is the radical axis. Clear? Radical axis between the two circles. Is this clear, everyone? Tell me quickly in the chat box. How many of you understood this? Everyone, quickly reply me in the chat box. How many of you understood this? Is this clear, everyone? Clear? So the radical axis, देखो आपको you don't have to remember this definition. Okay, which equation you have to remember? This equation. This is actually what you have to remember. This. Remember this definition. Okay, that radical axis between the two circles is just given by subtracting the two circles. That's all. First of all, make the coefficient of x square y square 1 and then subtract the two circles. That will give you the radical axis. S1 minus S2 equal to 0 will give you the radical axis. Is this clear? Very good, Vishal. Very good, very good. Okay, so what you have to remember is radical axis can be derived by subtracting equation of two circle after making coefficient of x square and y square 1. So radical axis can be derived by subtracting the equation of the two circles only after making the coefficient of x square and y square 1. As you can see, the radical axis is some line, yes or no? Ax plus by plus c equal to 0 type की form आ रही है ना radical axis की. So radical axis is a line. Okay, is this clear? So how you have to find the radical axis? Just two circles are given, subtract these two circles, so you will get the radical axis. Is this clear, everyone? Do you have any doubt with this? Is there any doubt? Is there any doubt? Okay, if it is clear, then let's see some property of the radical axis, and these are the very important property that can save you so much time during the exams also. Okay, so the first property of the radical axis is, let's say two circle. See, this is the first property. It's saying that if two circle intersect, then radical axis is a common chord of the two circle. Let's say this is a circle S1 equal to 0 and this is another circle S2 is equal to 0, and these two circles are intersecting at point A and B. Yes or no? So AB is a common chord. If somebody asks you to find the common chord of these two circles S1 and S2, so you have to remember that this common chord is also the radical axis of the two circles. So simply this is also a radical axis. Yes or no? This is also a radical axis. So common chord which is radical axis can be given as S1 minus S2 is equal to 0. Simple. Is this clear? If somebody asks you in the question, find the common chord between the two circle, then अगर दो सर्कल है तो ये इंटरसेक्ट कर रहे होंगे, then only you can find the common chord. Otherwise कैसे find करोगे? Then you should remember, if two circles are intersecting, then the radical axis is nothing but the common chord of the two circles. And how you find the radical axis? By subtracting the equation of two circles after making the coefficient of x square y square 1, obviously. Okay, so this is a very first property, that if two circles are intersecting, then the radical axis is the common chord of the two circles. Is there any doubt in this? These are the facts that we have observed. Okay. Okay. Proof are not important. Okay. Proof are not important. Okay. Just these properties you have to remember directly. Okay. In the competitive exam, directly you can solve some question with the help of radical axis also. Okay. We will solve couple of questions on the radical axis. There you will see how much important it is. Okay. But continuing with the properties of radical axis, second property is, if two circles are touching each other, if two circles touches each other, then radical axis is the common tangent of two circle at the point of contact. Means if two circles are touching each other, let's say this is circle S1 and circle S2 is something like this. This is circle S2. Then the common tangent at the point where they are touching, this is nothing but common tangent, and which is also the radical axis. Okay. So this is a radical axis between the 2 points. Radical axis between the two circles. Okay. So if somebody asks you what is the point, find the equation of tangent where the two circles are touching each other. So simply, if two circles touching each other at, let's say, this point P, then the common tangent at this point P will also be the radical axis between the two circles. Then this common tangent can be given as S1 minus S2 is equal to 0. Directly you can find the equation of common tangent. Clear? Common tangent at the point of contact only. I'm not talking about this is what you can see. This is a transverse common tangent. Yes or no? Because C1 is here, C2 is here. Not the direct common tangent. Don't get confused with the common tangent. I have already written here at the point of contact. So the common tangent that I'm talking about is the only and only the tangent at the point of contact, which is a transverse common tangent by observing. Okay. Is this clear? So if two circles are touching each other, then the tangent at the point of their contact is nothing but the radical axis only. Is this clear? Is there any doubt, students? Is there any doubt? Students, is there any doubt with these two properties? Okay. Okay, very good, very good. Okay. Now let's move on to the third property. Third property is, if two circles are separated, let's say there are two circles. Okay. Very good, Bhumika. Very good. If two circles are separated, let's say this is a circle S1 and this is a circle S2. If these two circles are separated, then the radical axis will passes outside the circle. So this would be somewhere radical axis. Okay. Two circles are separated, then the radical axis will pass outside of the circle. That's it. Okay. So this is the third point. Okay. And the fourth point is, it is very important point. Okay. Radical axis is always perpendicular to the line joining the center of the circle. Let's say this is a circle S1 and this is a circle S2. Okay. As you can see, these two circles are separated. So from the third property, we can say that radical axis will be passing outside of the circle. So this is nothing but radical axis. Radical axis. This is center C1. This is center C2. So now join the C1, C2. So the radical axis is always perpendicular to the line joining the center of the circle. Very important property. So this radical axis is perpendicular to C1, C2 line. Is this clear, everyone? Is this clear, or do you have any doubt with this? Quickly let me know in the chat box how many of you have doubt, or how many of you got the clear understanding of the radical axis. Is there anyone in the class who doesn't understand till now? All clear? Okay. So the first property was, if the two circles are intersecting, then the radical axis is the common chord. Second property was, if the two circles are touching each other, then the radical axis is the common tangent at their point of contact. Third property is, if two circles are separated, then radical axis will pass outside of the circle. Fourth property is, radical axis will always be the perpendicular to the line joining the center of the circle C1, C2. Clear? Okay. If it is clear, so let's solve one question on the basis of radical axis. Okay. Let's solve this question. Okay. I'm giving you 1 minute first to attempt this question. Okay. 1 minute you have attempt this question. Tangent are drawn to the circle. We have drawn a tangent to this circle at the point where it is met by this circle. Means that these two circles are intersecting at 2 points, and at those point of contact I have drawn tangent on the circle x square plus y square equal to 12. So the question is find the point of intersection of the tangent. That's it. Okay, you have 1 minute. Everyone attempt this question and let me know the answer in the chat box. Everyone attempt this question and let me know the answer in the chat box quickly. What is the answer? Point of intersection of the tangents. Everyone quickly. Answer. Students, start attempting this question. Okay, let me know the answer. Point of intersection of the tangent. Okay, try to think how you can use the radical axis. Obviously अभी क्वेश्चन में radical axis के बात करा रहा हूँ, तो radical axis ही यूज हो रहा होगा. But the point is in the exam how you will think, right? Okay, tell me, is there anyone who got the answer of this question? Anyone? Shall I start the solution? Is there anyone who is getting the answer or should I wait for them? Okay, let's see. So student, question is saying that this is a circle x square plus y square equal to 12. Let's say this is a circle. This circle is x square plus y square. Let's say minus 12 is equal to 0. Okay. And this circle is intersecting with the circle x. Let's call this circle S1. Okay. And this circle is intersecting with the circle x square plus y square minus 5x plus 3y minus 2 equal to 0. Okay, so maybe somewhere like this the second circle is here. Okay, क्या फर्क पड़ता है, सर्कल मैट कर रहा है, क्वेश्चन ने दे ही दिया, तो पॉइंट ऑफ इंटरसेक्शन से टेंजेंट ड्रॉ करनी है, तो सर्कल इंटरसेक्ट कर रहा होगा. लेट्स से दिस सर्कल इज इंटरसेक्टिंग एट दीस 2 पॉइंट्स, सो दिस सर्कल S2 इज x स्क्वायर प्लस y स्क्वायर minus 5x plus 3y minus 2 is equal to 0. Clear? Now the circle are intersecting at these 2 points, and on the point, from the point of intersection we have drawn the tangent on this circle, so like this. Okay, so let's call this point A and let's call this point B, and this tangent are intersecting at the point P point. Let's say x1 comma y1. Is this clear? And this is AB. Is this clear, everyone? Situation of the question is clear? Is there anyone who didn't understand the question till now? So we have to find the x1 comma y1. That's it. Okay, this is the question. So first, how you will start proceeding? First of all, with respect to point x1 comma y1, point P which is x1 comma y1, AB is a chord of contact. AB is chord of contact on circle S1. Yes or no? AB तो chord of contact की तरह behave कर रही है ना with respect to this point on the circle S1. So what is the equation of chord of contact? T equal to 0, right? We have already discussed chord of contact is T equal to 0. So what is the equation of the chord of contact? Replace x square with x1, so x into x1 plus replace y square with y1, y into y1, constant term as it is, minus 12 is equal to 0. So this is equation of AB as a chord of contact. Clear so far? So far clear? Okay, but these two circles are intersecting. AB is also a common chord. Yes or no? कुछ याद आ रहा है? But AB is also common chord of S1 equal to 0 and S2 equal to 0. S1 and S2 सर्कल के लिए AB तो कॉमन कोड की तरह भी काम कर रही है ना. एंड अभी प्रॉपर्टी पढ़ के आ रहे हैं रेडिकल एक्सिस की. इफ टू सर्कल आर इंटरसेक्टिंग देन द कॉमन कोड is a radical axis. Radical axis is a common chord. Is this clear? So you can say that it implies AB is a radical axis also. AB is a radical axis also, right? So what is the radical axis? Equation of radical axis. So equation of AB can be given as S1 minus S2 is equal to 0. What is x1? S1 minus S2. S1 is x square plus y square minus 12. What is S2? S2 is x square plus y square minus 5x plus 3y minus 2 equal to 0. Clear? So what you are getting? Minus 12 plus 5x plus 3y plus, sorry, one second. Yes. What we are getting? We are getting minus 12 plus 5x minus 3y plus 2 is equal to 0. So 5x minus 3y minus 10 is equal to 0. This is equation 2. This is also the equation of AB. So both equation 1 and 2 are representing the equation of AB only. Yes or no? So it implies first equation and second equation are exactly identical. If both equation 1 and 2 are exactly same, so it means ratio of their coefficient of x, y and constant should be equal. So what is the constant? What is the ratio of x1? X here, x1. So here I'm writing equation 1 and equation 2 are identical. Yes or no? So you can say that ratio of their coefficient is equal. So x1 upon, what is the ratio of the x here? 5 is equal to, what is the coefficient of y here? Y1, and here minus 3. So y1 upon minus 3 is equal to, what is the constant term here? Minus 2, minus 12, and here minus 10 is equal to minus 12 upon minus 10. So you can say that if you compare these two, you will see that x1 कितना आ गया? x1 is 6 only. And if you compare these two, what is y? Y is minus 3 into 12 by 10. So this is 6, this is 5, right? So y is nothing but y1 is nothing but minus 18 by 5. So it implies x1 comma y1 कितना आ गया फिर? Point P कितना आ गया? 6 comma minus 18 by 5. So this is the point of intersection of these tangent. This is the answer. Is this clear, students? Is this clear? So the point of intersection of the tangent is 6 comma minus 18 by 5. Yes or no? See, if you don't know the concept of radical axis, तो इस क्वेश्चन को करना थोड़ा डिफिकल्ट होगा ना? Yes or no? तब तो आपको इनके सॉल्व करके you have to find the point of contact only. Yes or no? So that's why if you know the radical axis, then the solution of the questions becomes so easy. So that's why in the starting of the radical axis, I have told you that this is a very powerful tool. Okay, so many questions can be done in so much less time if you know just the radical axis component concept. Is this clear, students? Tell me quickly in the chat box how many of you understood this question. Quickly, everyone, tell me quickly in the chat box how many of you understood this. Is there anyone who have doubt with this question? All clear? Okay. If it is clear, students, so that's all for today, everyone. So students, I'm launching a NPS poll. Okay. So please, everyone, participate in the poll before going out. Okay. Before leaving the class, everyone, please participate in the poll. And in meanwhile, I'm sharing the homework question for the today's class. Okay. These are the homework questions. So these are the homework question, everyone. Please note down this question. Okay. Please note down this question, everyone. Everyone, please answer in the chat box. Please answer the NPS poll, everyone. Before leaving the class, you can participate in the NPS poll and then you can leave the class. If you have any doubt, you can ask me now. Okay. Thank you, everyone. Take care, everyone. Everyone, let me know the answer in the chat box. Yes, very good. Thank you, everyone. Thank you.